Okay, in example 3, we are now going to go in reverse. So in example 1, we started with an expression with multiple logs in it, and we condensed into a single log. Now we're going to go in the other direction, starting with a single log. We're going to expand it as much as possible into multiple logarithmic terms in the expression. So we're going to look at the structure here, and we have an exponent of 3. So using the power property, we can change that exponent on the argument to a coefficient on the log expression. So that's going to be a 3 times the natural log. And then in the numerator, we've got a product. So the natural log of 2x can be expanded into the natural log of 2 plus the natural log of x. And then in the denominator, we have a y, and that would be the quotient property. So we use a subtract and then the natural log of y. And to get rid of the parentheses, then we'll distribute that 3, and we'll have 3 natural log of 2 plus 3 natural log of x minus 3 natural log of y. And that would be our completely expanded form for example A. In example B, we have grouping the argument of the log together is a cube root, and a cube root is the same as a 1/3 power. So again, I can start by using the power property to move that cube root to the front as a coefficient of 1/3. Then I have a common log, and this is just a product inside of the argument. So we have a common log of x plus, using the product property, a common log of y squared. And that exponent, we can apply the product property to make that a coefficient on the log of y. So now I'm going to remove these parentheses and simplify. So distributing 1/3 log of x plus, and then this power of 2 comes forward with the power property, and 2 times 1/3 is 2/3 log of y. And that would be my completely expanded and simplified form for example B. Okay, then go ahead and pause the video, and you're going to try example 4 on your own. See if you can expand this log base 2 of the quantity square root of x over 4y cubed into sum and difference of individual log expressions and simplify. Okay, when you're ready to check, you can resume and we'll go over this one together. Okay, let's go over example 4 together. So we've got a log base 2 of the quantity square root of x over 4y cubed. So since the square root of x is in the numerator, then I'm going to have a positive log base 2. And an x, square root of x is the same as x to the 1/2 power. Okay, then the 4 is in the denominator, so that's going to be a subtract log base 2 of 4. And the y cubed is also in the denominator, so that'll be a minus again. and then log base 2 of y cubed. I'm going to use the power property in order to make those exponents into coefficients. So then I have a 1/2 log base 2 of x. Here in the middle, the log base 2 of 4, that expression can be evaluated. Log base 2 of 4 is equal to 2. So I'm going to simplify that term into -2. And then my last term, using the power property, I pull that coefficient 3 from the power, and then my log base 2 of y. And that would be my fully expanded form that's been simplified. So 1/2 log base 2 of x minus 2 minus 3 log base 2 of y. Okay, that brings us to the secret question for this lesson. In the first problem, you're going to use properties of logs to condense this expression into a single natural log and simplify. And then in the next problem, you're going to do the reverse. You're going to use the properties of logs to take the single log expression and expand it into its fully expanded form of common logs, added and subtracted together. Okay, when you've finished with these two problems, you can upload your work as the last page of your notes to Schoology, and then you'll answer the 2 secret question problems in the secret question assignment in Schoology to check your answers.